My absolute favorite food? Pizza's good. That's kind of my cheat food. You know, when I'm going to have a little more, I go for some pizza. This is going to start as a weird recording for anybody who just happens to watch it. Okay. All right, so here's what we're going to go ahead and do. I passed back your quizzes. Let you go ahead and take a look at that. So our first, yes, Johnny. I like pepperoni and hamburger.
Wait, what was the question?
Anyways, he asked what kind of pizza I like. Anyways, oops, sorry. Oh, these are my notes. I'm sorry. Okay. So we're going to go ahead and start with the quiz today, any questions you might have. And then after that, I'm going to go ahead and wrap up the lesson over geometric sequences and series. And then I thought we'd go ahead and just spend the rest of the period looking at the assignment, because the assignment for which is due tomorrow. And we also have a quiz over geometric sequences and series tomorrow as well. So, yes, sir. So what I'm planning on doing this week, what's due on Thursday? That's the IA. Okay, remember we talked about the expectations. You want it to be typed, all that good stuff, you know, stapled with a, this is just a rough draft, yes. I'm going to give you feedback on it. That's why I'm looking for a hard copy so I can, you know, write my thoughts on it as I go ahead and read through it. Anything you might need to change to your data, whether quantity, quality, strategies, all that good stuff, I'll be just kind of giving some pointers and feedback. And again, remember, that's all it is. It's just my personal opinion. Ultimately, what it comes down to, this is your project. If you still want to go in a certain direction, you know, absolutely feel free to do so. But what I want to do, besides the assignment and the quiz, whatever time we have left tomorrow, I want to go ahead and give you guys, just in case you're not quite ready to turn in your IA. I also want to give you the class period on Wednesday as well. We are ahead at this point, so it's not going to hurt us. I'll go ahead and start grading these on Thursday. And remember, I'm not here on Friday because that's exactly what I'm going to be doing. So the substitute's going to be left that semester review that we were talking about last week. All right, so any questions about what's happening this week? No? Okay, well, let's take a look at this quiz. Were there any questions on the quiz that we want to talk about? Number 4. Okay. So an arithmetic sequence has the first term 8. So I know u sub 1 is equal to 8. The common difference is 2. The sum of the terms of the sequence is 170. Find the sum of the terms in the sequence. Okay, now this quiz, I went ahead and provided you all the formulas you were going to need, and there were 2 summation formulas when we're talking about arithmetic sequences and series. I opted to go with this one. We're adding what terms? Well, I'm just going to give you the formula. S sub n is equal to n divided by 2, and then we double the first term, plus n minus 1 times the common difference. Okay. Now, we're just working backwards. We want to know how many terms for this particular sequence would it take in order to add up and get 170. So that's what I'm going to go ahead and start with. 170 equals. I don't know what n is, but we do know the first term. So what would 2 u sub 1 be? That would be 16 plus n minus 1 times d. The common difference is 2. All right. And from here, we just go ahead and start to simplify. And as we've seen before, this actually turns out to be a quadratic function. So let's see here. I'm going to go ahead and multiply through by 2 to go ahead and cancel that out. What if I double 170? 340 is equal to, okay, so this would be 16 plus, I'll just go ahead and write it out. N times 16 plus 2n minus 2. Okay, so 340 is equal to, that would be 2n squared plus 16n minus 2n plus 14n. So 0 is equal to 2n squared plus 14n minus 340. Okay. Now, if I were to solve it here for n, it's going to give me the answer I'm looking for, but when you have everything on one side, and we're going to be talking about this in the next lesson, if a, b, and c, the coefficients of n squared, n, and your constant, if they all have a common factor, you can reduce it. Now, it's going to give you a different quadratic, but that variable, the value will stay the same. So here, what divides 214 and 340? Okay, 2. So this would be n squared plus 7n minus, we get back to 170. And remember, we talked about a variety of ways. We talked about how to do this in the calculator, completing the square, quadratic formula. In fact, this one factors very nicely. I'm looking for two numbers that'll multiply to give me a 170, a negative 170 that is, but add to give me 7. Does anybody know those straight off?
17 and negative 10.
17 and 10. There we go. Okay. And the 10 would have to be negative because 17 times negative 10, but 17 minus 10 is the positive 7. You always have to make sure it matches up with that linear coefficient. Well, how would I solve this? And that's a 17 right there in the middle. There we go. How would I now solve this for n? Do you guys remember what property this is? Starts with a Z. The zero product property. There we go. So what this means is if I'm multiplying two terms and the product is 0, then either one or both of the values has to equal 0. So n plus 17 is equal to 0, or n minus 10 is equal to 0. So n is either negative 17 or n is equal to 10. Is there one answer I can get rid of? Yeah, the negative 17. No, we're not looking at a negative number of terms. So it would have to be the first 10 terms of that sequence that'll add to give me 170. Who asked about this one? Joey? Number 4? Okay. Is that good? All right. Anything else? No? Oh, okay. Okay. Oh, sorry, Kate. I wasn't even looking. Kate's at the back. It's darker. 3B. I was like, why's everybody looking? Okay. All right. So consider the arithmetic sequence 9, 15, 21, ... 69, 75. So we might as well just go ahead and start with A. Find the common difference D. How do I get from a 9 to a 15, from a 15 to a 21? Six. There we go. Remember, because it's arithmetic, you're just adding or subtracting the same value over and over again. So you can take a term and immediately subtract the prior term. So like 21 minus 15 will give me 6. And hopefully it should be the same value over and over again because that would represent your slope. Okay, so find the number of terms in the sequence. So how many terms is it going to take going by this pattern to get from 9 to 75? Well, what I did, I used the nth term formula. U sub n is equal to the first term plus n minus 1 times d. So if I'm wanting to know how many terms it takes from 9 all the way to 75, I went ahead and set it equal to 75 because that's the last term. And I went ahead and solved for what? What do you think I solved for in the equation? N, because that gave me that number term, and that'll tell me overall how many I'm looking for. So the first one was 9 plus n minus 1 times 6. So 75 is equal to 9 plus 6n minus 6. Okay, so 75 is equal to, that would be a 3 plus 6n. So now what does 6n equal? 72. And we see that n would equal 12. So it should take 12 terms if I'm just adding 6 over and over again, starting with 9 to get to 75. Okay. Did you want me to do C? No, that makes sense? Okay. Anything else? Okay. If you do end up having any other questions, let me know. You can definitely retake this. I know it's probably Thursday morning, I think, when I set that deadline. I'd have to look at the website, but I'm pretty sure about that. Unfortunately, there won't be any tutorials on Friday morning. Why is that? Because I won't be here. I mean, I'll be here, I just won't be in the classroom. In fact, I'll be down the hall. Okay, do you want to save changes? Why not? All right. Well, I kind of want to pick up on something that Mr. Yacht discussed with you the other day. It was the summation for a geometric series. Let's see here. Here, where we had these two formulas right here. Did anybody happen to go ahead and choose the other formula that you didn't use on this particular problem and see that it gives you the same result? Okay, I wanted to go ahead and start here and just show you that while IB distinguishes between the two, whether your common ratio is smaller than 1 or it's larger than 1, it actually doesn't matter. If you use either formula, it's going to give you the same answer. And let's go ahead and choose one. Let's say this one right here. Algebraically, I'm going to go ahead and simplify this so that it looks like the other one. So I've got u sub 1 times 1 minus r to the n over 1 minus r. Okay. So let's say I were to go ahead and rewrite it as u sub 1 times 1 minus r to the n over negative r plus 1. Would you say that's equivalent? All I did was switch it around in the denominator. The r is still negative. The 1 is still positive, right? Okay, so now in that denominator, what if I went ahead and factored the negative out? Okay, so if I factor out a negative 1, that would leave me r minus 1, right? And then if I were to redistribute negative 1 times r, negative 1 times negative 1, okay. But now let's apply this negative 1 to the numerator. But here's the thing, we've got a product up there. We've got a monomial term times a binomial expression. Do I need to apply the negative to both of these? Like if I have a product, just think, if I have, 2 times 3, and I want to go ahead and multiply that by a negative 1, do I multiply both 2 and 3 by the negative? I don't have to. If I just multiply by 1, see, it's already multiplied by the others. It's already considered part of the product. So here, I don't have to make both u sub 1 and 1 minus r to the n negative. I'll just apply the negative, though, to this. So that would be u sub 1 times negative 1 plus r to the n over r minus 1. But negative 1 plus r to the n, well, isn't that? Wouldn't that just be r to the n minus 1? And what do you notice about that particular formula? Okay, it's that second formula. So again, I'm not sure why we're actually making a difference between the two formulas, saying you have to use this one if it's a less than 1 ratio. If it's a greater than 1 ratio, you use the other one. I just really wanted to go ahead and point out, if you use either, you're going to get the correct summation. Okay. Questions on that? Okay. Now, I know there was a few questions left in the notes, but I thought it would probably be more beneficial if we just went to the homework and started practicing this, because there was one problem in particular that I wanted to go ahead and take a look at, and it was number 6. Okay, because this type of problem, I think there were still some people on Thursday who were a little confused about it. So this is a perfect opportunity to kind of revisit that type of problem and hopefully fill in any gaps or misconceptions. Has anybody finished up the homework yet? Oh, almost? Okay. You will finish it? Okay, I do like the sound of that. All right, let's take a look at number 6. The initial population of rabbits on the farm was 50. The population increased by 7% each week. How many rabbits were present after 15 weeks and then 30 weeks? And then B, how long would it take for the population to reach 500? Whew, if you're like me, you probably don't care at all for this problem. Don't care at all. It's a rabbit, rabbity carrot. Still got it. Okay. So let's go ahead and go back to the beginning. Okay, so this is our problem we're solving. But put this aside for just a second. What's the formula for the nth term of a geometric sequence? U sub n equals what? U sub 1, so the first term times r to the n minus 1. But what we were talking about yesterday, a couple of the problems, now when it came to the application, we went ahead and put it in terms of an exponential model. So we went ahead and said the amount after whatever given time there was going to equal, u sub 1 times r to just the n power. Okay. So what I was trying to show you the other day is that both of these are going to be correct. They're both going to go ahead and give you the sequence that you want to generate. But you have to think about what each formula is doing. Like, for example, what I already did, I came in early this morning and I went ahead and did a side-by-side comparison. So we're starting with 50 rabbits, right? Okay, so that's U sub 1. Where'd the 1.07 come from? Remember, it's increasing by 7% each week, right? So I went ahead and took the idea 1 plus the 0.07 increase that we have per week. So I have one where it's just raised to the n, and I have one where it's raised to the n minus 1 power. Well, look at these side by side. I started with 0, and I went all the way down in the first column to 30, and the other one to 31. What are you noticing? Now, except for the first terms, are they generating the same sequence? Yeah, they're going to generate the same sequence. Now, what a lot of people prefer to do when we're looking at these application problems, now, if you're going to be asked, here's just a straight sequence, find me the nth term, you're going to go ahead and use this n minus 1 version. But you can actually use either, but the reason a lot of people prefer to go ahead and start here is because the first term would be after the given amount of time. Because the question is based on number of what? It's increasing per week, right? It's increasing per week. So for example, if we just started this experiment and I say, okay, how many rabbits are there right now? How many weeks would there be? See, I have to start with week 0. All right, so that gives me the initial amount. So what I go ahead and plug in, that's actually the number of weeks. Well, kind of look what happened in the other case here. When I plugged in 0, that gave me -1. So this formula, if I plugged in 0, is actually telling me that there would be like 47 rabbits when? 1 week ago, because I got a power of -1, right? So if I were to continue down through here, n equals 1 gave me 50, n equals 2 gave me 53.5. So you'll notice it's just off by 1. N equals 0 gave me 50, n equals 1 gave me 53.5. So if you're going to go ahead and use the n minus 1 version, if you're asked, for example, okay, well, what's the 15th week? You actually have to go ahead and plug in 16. Okay. Also think about algebraic or graphically. What's the difference between the n minus 1 and the n? What kind of transformation is that? Now here it's n, but we would normally refer to that as x, right? It's directly affecting x. Would that be horizontal or vertical? It would be horizontal. Can anybody tell me what kind of transformation that would be? Would it be a reflection? Would it be a translation or a dilation? Now, Jacob's already saying translation. That means a shift. So what direction would it be shifted, though? Left or right? Yeah, so n minus 1 power. Would not shift it to the left. It would shift it to the right. The thing about the x's and horizontal transformations, they're always trickier than the vertical. If you're adding and subtracting to x, you take the opposite direction. So because it says -1, you would actually shift it 1 to the right. Okay. Does anybody remember if I happen to multiply by x? What's the key word when I multiply by x? I have to take the what? You have to take the reciprocal. The reciprocal is the true scale factor because that's a dilation. In fact, I also went ahead and graphed these. Here's a side by side. You'll notice the original to the x to the n power is in blue, and then 50, 1.07, x minus 1, the n minus 1 is in red. So that graph is just shifted 1 to the right. Okay, so it is true when you're dealing with an application problem like this, you can use the n-1 version. You just have to add 1 to whatever term you're looking for in order to make it consistent. We're just shifting the number of terms over. Does that kind of help? Okay, yes. That's up to you. That's completely up to you. What I'm saying is you can use either one. Now, if this wasn't a application problem, if it wasn't anything in the real world, if it was one of the others, here's the sequence, find the 8th term. I would absolutely go ahead and use the x-1 version. But with the application, you have your choice. You just have to realize what's going to happen. Yes, ma'am.
I think one thing for me that helped on this is that, like, if you're talking about it in terms of time, time is continuous, and so you can't just have, like, because you can also have, like, 1/2 of a week or whatever.
True.
And so
True.
the number of rabbits that are going to be created are going to be different at 1 week, 1/2 a week, and 2 weeks. And so by doing it just you're starting at the beginning of the week, not at the end.
Okay, I
That's
like the way you said
I
that.
think about it,
Okay.
at least.
Good. Does that kind of help people now, kind of distinguish between the two? Ella, what was your question?
Sorry, I had a question about like how we're supposed to route these.
How we're supposed to round these? Oh, and see, here's the thing. There's actually, people who are going to fall on both sides of this. Like, for example, if I look at this right here, you'll notice when I plugged in n equals 0 here and got the negative power, that told me that I had 46.729 rabbits. Well, in a realistic setting, you're not going to have a portion of a rabbit. I mean, we could, but that's kind of gross and dark, But so here's the thing. Some people would go ahead and say, no matter the decimal, if you got a portion, you would go ahead and round up. But then there are also people on the other side of that who said, it doesn't matter if you got a portion, it doesn't represent 1 unit, so you would round down. Personally, I kind of fall with whatever the decimal says. If it happens to be like 5 or more, I tend to go ahead and round up. So on this one, I would probably say 47 rabbits. Okay. I would probably only have said 46 rabbits if it turned out to be 46.4 or below. Okay. So like 2 weeks, I would have said 54. 3 weeks, I would have said 57. I would have said 57 rabbits. Does that make sense? Okay. All right, I just wanted to go ahead and make sure that was thrown out there so that everybody hopefully is okay. All right. The only thing I didn't do is C, because this one has B, because I think A was 2 parts, right? There we go. Okay, so the 15 and the 30 weeks, so we already got that. All right. So where would you like to go from here? Would you just like to go ahead and continue looking at the assignments? Number 5? You want to do 3 as well? Okay. Okay, so we'll go to 3 and then we'll do 5. Okay, so it says show that the sequence 8, 4 square root of 2, 4, 2 square root of 2 is geometric. Hence find in simplest form the general term u sub n. Okay, so what that means is, simplify the formula as much as we can. Like, what formula, what little expression would give me any term number I want? Well, we just talked about the fact that if it's arithmetic, we can take a term and subtract the previous term. What do I do if it's geometric? How would I find that common ratio? I would divide it, because geometric sequences are based on multiplication. So let's take 4 square root of 2. If I go ahead and divide it by the previous term, 8, looks like I'm going to get square root of 2 over 2. I can go ahead and check this again. 4 over 4 square roots of 2. Okay. Now this is going to give me 1 over square root of 2. Does anybody remember what I'm referring to when I say we rationalize the denominator? Does that sound familiar? There you go. If I want to remove the square root from the radical. Now here's the thing. I want to go ahead and multiply this 1 divided by square root of 2 by some value that keeps the same value, but it just changes the way this looks. Okay, thank you. I don't want a radical in the denominator anymore. So what can I multiply the square root of 2 by that will give me a perfect square root? Square root of 2. Now it only works for those square roots. If I multiply a square root by itself, the square root of 2 times square root of 2 is square root of 4, which is 2, right? That's the whole point. We want to multiply by something that's going to remove the radical. But I'm going to go ahead and put the same value up here. What's the value of the square root of 2 divided by the square root of 2? Well, it is square root of 2 over square root of 2, but it's just 1, right? We're multiplying by a version of 1, because what happens to any number if you just multiply by 1? It stays the same. So we're just multiplying by a version of 1, so this would give me square root of 2 over 2. So see, I got the same ratio again. So I could even, take another pair of consecutive terms, go ahead and divide them, and I should be able to get that over and over again. So that would be enough to show that this is geometric. Okay, that I can divide a term by its previous term and I get the same ratio. Then it says, hence find in simplest form the general term u sub n. Okay, well I already know r was equal to the square root of 2 over 2. U sub 1 was what? 8, right? Now, the nth term for a geometric sequence was the first term times r to the n minus 1. So u sub n is equal to 8, first term, times the square root of 2 over 2 to the n minus 1. And this is one trap that I always see students fall into when we're talking about exponentials, and even when we're talking about geometric sequences and series. Can I multiply the 8 times the square root of 2 over 2? I cannot, because that's not really a square root of 2 over 2. The value of that depends on what I plug in for n. Hello. It'd be like if I were to give you something like this. If I had 2 times 3 to the x, I cannot say that's 6 to the x, because that's not really a 3 right there. Okay, now if x was 1, then I'm going to get 6, but for anything else, that's not going to work. Okay. Who asked about number 3? Ella? Is that okay?
Yeah. Just don't like.
Was it the rationalizing part?
Yeah.
We got to the root of that problem. Pretty radical. Well, yeah, they're all good. We've talked about this recently. All right, let's move on to number 5. A geometric sequence has a second term of -6 and a fifth term of 162. Find its general form. Okay, so it's referring to this one again. U sub n is equal to the first times r to the n minus 1. Well, I only need 2 things. If I know the first term and the common ratio, problem's done. Okay. Well, this one's actually very similar to what we did on our notes. I would go ahead and apply what I know separately to this formula right here. So for example, I can go ahead and say -6 equals u sub 1 times r, but what would my power be? What term number is -6? Okay, it's the second, right? So I would just plug 2 in here, just like I plugged the -6 in here. So that would just be r to the first. Now I'm going to do the same thing for the other one. I know that the fifth term is 162. So I'm going to say 162 is equal to the first term times r. But what power would I have here? Remember, what term number is 162? It's the fifth term. So I would actually have this to the 5 minus 1 power, because that's what my exponent is. So this would actually just be r to the fourth, right? Okay. Does anybody remember where I can go from here? How did I solve one like this in the notes? Substitution. Actually, that's what I did. I created basically a system. I solved each of these for u sub 1. So this first one would be -6 divided by r. The second one, u sub 1, would equal 162 divided by r to the fourth. Okay. So because the two ratios both equal the first term, they can what? They can equal each other. So I'd say -6 over r equals 162 over r to the fourth. And how do I solve a proportion? Cross multiply. So I've got 162r is equal to negative 6 r to the 4th. Okay. And my goal is to solve for r first. So I want to go ahead and isolate this. I know which one I would divide by. Would you go ahead and divide by r or r to the 4th? What would save you a step? I divide by r. Okay, because let's say, excuse me, I went ahead and did it the other way. 162r is equal to negative 6 r to the 4th. Let's say I went ahead and divided by r to the 4th. That's going to give me 162 over r cubed, or 162, or I put 162, yeah, I don't know what I'm doing. 162 times r to the negative 3. And then you'd either still have to deal with this fraction or go ahead and deal with the negative power. So I went ahead and divided through by the r. So those are going to cancel. But at the same time, I'd go ahead and divide by what? Negative 6. Okay, so r to the 4th over r would give me r cubed. Those are going to cancel. What's 162 divided by negative 6? Negative 27? Is that right? Okay. And how would I get r from r cubed? Cube root. Okay. Is this going to go imaginary? Why not? I'm taking a root of a negative number. Only if it's even. Only if it's a square root, a fourth root, and so on. So if you're taking an odd root of a negative number, then the answer itself will be negative. So I know that my common ratio has to be negative 3. Is everybody okay with that? So now I can just kind of start to work backwards. Let's go ahead and use this one right here. I know that negative 6 equals the first term times r. Well, we just found that to be negative 3. So the first term should be what? Okay, 2. There we go. And now we just go ahead and write out my formula. What would u sub n equal? 2 times negative 3 to the n minus 1. Oh, wow. How close was that to the example I just gave you when I was showing you can't multiply by the base? That's insane. Even my future self knows what's up. Kind of. All right. Who asked about this one? Amy? Does that make sense?
Yeah, I just saw R the first time, and then you have to take the fourth root, and I was like,
Yeah, and remember, this is just the first idea that I had. Remember, there's going to be other ways that you can solve these problems. It's not just this is the one and only method. Okay, so definitely not a bad idea. If you have an idea, go ahead and run with it. Okay, and then see what happens. Okay, I've got 158. Yes. Number 4. Okay. Now this is a good one. Now I know you guys just had a 3-day break, but you're probably already tired of listening to my voice. I've been talking the entire period. You're like, I want to hear somebody else. Who would like to come on up and show me this number 4? Oh, Jacob? Are you sure? You just said something.
I said number 4 to confirm that it was.
Oh, confirm that it was number 4. Nobody? Okay. Well, this isn't going to be 100% accurate, so I'll just go ahead and choose somebody here. Okay, random integer. Okay, we got 1, and there are 34 people in this room. 5.
oh, what the heck?
Look, said it, 5.
I don't know how to do this from.
That's okay. Perfect reason to come on up. Okay. And Cigna thanks you. There you go. All right, so let's say you have a problem like this. Okay. We had a problem very similar to this on the arithmetic assignment, or that review that we just did last week, in fact. Okay. Think about what we did there, but what would I do here now that it's geometric? K minus 1, 2k, and 21 minus k are consecutive terms. of a geometric sequence. Find K. Oh, and I forgot to ask, did you want the... No, you don't want to talk into the speaker? Okay. Everybody else did it the other day. They enjoyed it. Peer pressure. Okay. Okay, well, think about what we've done today. Like, we had a question a second ago, number 3. How did I show that was geometric? There we go. So I know, now we don't know what the terms are, but I know that k minus 1 is a term in the sequence. I know that 2k is the very next term. 21 minus k is the one that follows that.
Right, and then
So far, so good?
wow, that's about all that I have.
Well, now what would that give me? Now, I'm not talking in terms of algebra. It would give me r, right? So why don't we set that equal to r? But then couldn't I take 2k divided by k minus 1? There you go.
So that's the same as number 5.
It's exactly the same. Because we both know those ratios should equal r, what can I do with them? There you go. I can just set them equal to each other. 21 minus k over 2k equals 2k over k minus 1. Cross multiply. So 4k squared. So 21k.
Oh wait, you would have to do.
Yeah, you'd have to FOIL those, right? So your 21k was correct.
So 21k minus k minus wait. Oh, minus
Now it should be minus k squared minus 21 and then plus a what? Plus k. There we go. Now let's simplify it. 4k squared equals we have a negative k squared plus 22k minus 21. Is everybody okay with what she's doing so far? Good. Oh, Laura, are you okay? Okay, well, Ella, let's take a step back for just a second. Are you okay with, okay, where did we lose you?
See the second one underneath the first one. Okay.
Oh, okay. So you're good? Anybody else? Okay.
still divide this by like squared.
Now, I would get everything on one side. I'd go ahead and combine all my like terms and then see if there's a common factor.
But
Otherwise,
should I divide the negative k?
I like to go ahead and keep my k squared, my squared terms positive. That's just a personal choice. I would move everything to the left. But again, that's just me. If you moved it to the right, that's not to say it wouldn't be equivalent.
But then,
Now remember, we're not dividing.
yep.
We would add that.
Yep. Because it's subtract. So then, but then I would divide with 4.
Now remember, whatever you do to one side, you're going to do to the other, correct?
So I would add k squared.
Okay.
So it should be 6. No.
So that would be 5k squared equals 22k minus 21.
And then I would subtract.
And then, yeah, you can just subtract those over. So 5k squared minus 22k plus 21 equals 0. There you go. So there is your quadratic. Now we just need to solve it.
Could I do the negative b plus or minus
What do we call that?
quadratic?
Quadratic formula. You absolutely could.
So then why would you do this? I can't. Okay, so this would be is it the square root of b?
Of b squared. So negative 22 squared. And then, oh, not plus. Minus 4 times a times c. Okay. And all that's divided by, there you go. And now we just need to figure out what that is. Okay. So with the timer running out, you just want me to go ahead and type it in for you?
I do.
Okay. Let's do that. All right. Ella, good job. Yay! Okay, so let me do this. Control divide. 22 plus square root. It was a negative 22 squared minus, minus 4 times a times c, all divided by 2 times 5, 10. Okay, so I got 3. Now, what's the other change I would need to make? There we go. So delete, make that a minus. Okay. So this one turned out to be 7/5. Okay. In this case, you'd write both. Because remember, each k would make this a geometric sequence. So there are actually 2 answers. Okay. All right, good. We got less than 2 minutes. Okay, we will turn the homework in tomorrow. I'll answer whatever remaining questions you have. We'll take our quiz, and then the rest of the period I'm going to give you for your IA. Same on Wednesday.
So, okay, we want to hear Thursday.
If there's any copies left, just show me.
Okay, also,